Good morning, everybody. Welcome back. I'm just going to give you a minute or so to settle in. Maybe if your mics are not muted yet, please mute your mics and feel free to open your cameras. Then we can see some of you. Thank you. So, good morning, everybody, and welcome back to this webinar by EADTU. It's a webinar on AI in education. We already had a session on Tuesday focusing on ethics. For those of you who missed it, we will share all the materials tomorrow. So before the weekend, you'll have the recording and all the presentation material. But today we will focus on the topic of assessment. So the way AI has reshaped the world of assessment. And we have two presentations, one by the Open University and another by Tampere University for Applied Science. But we'll start with Mychelle and Liz. And let me shortly get your bios up. So Liz is director of SciLab and a senior lecturer at the Open University Law School. And Mychelle Pride is academic director, PVC students. And then, am I right, Mychelle, that PVC stands for Pro Vice Chancellor, I think? Yeah, very good. And they will be talking for the next 20 odd minutes or so. And then afterwards, we'll take some questions. So please, Mychelle and Liz, go ahead.
Thank you very much for that introduction, Stefan. And as Liz pulls it up, I'll just give you a little bit of background. So Liz is the main person behind this project. And this project that we are going to talk to you about is about how to ensure robust assessment in the light of generative AI developments. And Liz led a large team here. You can see all the research authors. We were across we have four faculties at the Open University, which covers all kinds of disciplines that you can possibly imagine. Next slide, please, Liz. I'll give you a brief research outline, and then Liz will talk in some detail. She's got some excellent data here about how well generative AI performs in light of assessment. And then we talk a little bit about the detecting generative AI and the impact of training, following up with some findings and recommendations. We had three key research questions. And the first thing we wanted to know, and we started this project, I think Liz was about 18 months ago. I can't remember now, maybe 2 years. I honestly can't remember how long ago we started it. But we wanted to know what types of questions are most easily or least easily answered by generative AI. And this is a time when everybody was very concerned about the future of assessment and what assessment means and what's the point of a university. Will we still have universities? So we wanted to look at that. And we also were curious to know whether or not it varied by discipline or by level, and whether or not if you provided training to markers on how to detect generative AI, would they would they notice? Would that improve? We had 59 different questions across 17 different types of questions. We said 4 levels. So we have in the UK, United Kingdom, we have at the Open University a level 0, which is an introduction to university level study, and then we have 3 different years at university. And then, as I mentioned, it was across all of our faculties, so 17 different disciplines. We had all of these markers, each marking a batch of 8 scripts. And what's really important to note is that the markers did not know which ones were generated by AI and which ones were generated by students. And actually, I should backtrack, my apologies. We were able to pull 944 scripts. We used scripts prior to generative AI becoming into the public domain, and we used scripts then that were generated by generative AI. And you can see there we had 472 in each batch, 354 generative AI scripts across both batches. And we did provide a short training. So they marked a batch of scripts, provided some training, and then they marked a second batch of scripts because we wanted to see the difference that the training might make. And the analysis that we undertook was a mixed methods approach. So you'll see from some of the data that was some excellent quantitative findings coming out. And for those of you who like the numbers and how that works, I think you'll be very pleased to see. And then we also, which was really important, we ran some focus groups and we talked to the markers to find out what their experience was. And we brought those two together to show, and we'll show you our findings later today. Thanks, Liz.
So I'm going to go through the results with you. So we were looking to see which assessments were more robust. So the first thing we looked at was how well does generative AI perform in the assessments. So what you can see here is the total from the 944 answers that we looked at. Across the bottom axis, you can see the different assessment types. So we classified the assessments into things like essay with a stimulus, essay no stimulus, essays that required evaluation, numerical calculations, reflections, etc. On the left-hand side, on the axis on the left, you can see the grade. So 1 was a fail, and 2 was what we call a pass 4, which is a third at UK universities. 3 was a 2-2. 4 was a 2-1, and 5 was a first or a distinction. So the higher the number, the more well the generative AI performed. So the circles were the average marks from the authentic student answers. Now, we selected at random the student answers from the 21-22 academic year. So it doesn't necessarily correlate to the performance of the whole group. It was a random selection. And the crosses with the average score of the generative AI scripts. So you can see that they are more or less the same. There were some where actually the generative AI did better, evaluating essays and report of an experiment. The generative AI actually did worse. But you can see that across the assessment types, the generative AI comfortably passed all of the assessment types apart from one. And that was something that we classified as an activity plan. And on that, and for that one, the generative AI failed. Every script that was generative AI failed. And so we wanted to look in a little bit more detail to find out why this was. And we discovered that the activity plan was a role play. The students were asked to imagine that they were a health policy consultant and to write a briefing to the government. And the important thing was that both the students and the markers were given quite a tight rubric guidance. They had to include information from their module materials, from the course materials, and marks were given to it. And also, although we shared this with the generative AI, obviously the generative AI didn't have access to those materials, and therefore the answers failed. Now, we were a little bit disappointed that generative AI passed so comfortably across our assessments. I should also add that in terms of the marks for the assessments, we did look at whether there was any differences across the different levels and across disciplines. And what we discovered was that generative AI generally scored much higher at the lower levels. So at the pre-university level and at the first year university level, where the questions typically are assessing knowledge of fundamental concepts and foundational knowledge, the generative AI did a lot better. It still passed, but scored more low marks when you got to the higher levels, which were involving critical evaluation. We were not able to discover any difference across different disciplines, partly because this level effect was so predominant. We couldn't detect anything suggesting particular disciplines were more or less easily answered by generative AI. So the other part of robustness is if these scripts are passing, the generative AI scripts are passing, can we detect can the markers detect which are generative AI scripts? And so the markers knew that there were generative AI scripts within the batch that they had. Crucially, they didn't know how many were generative AI scripts in each batch. And as they marked, we asked them to indicate if they thought a script was generative AI and the reasons why. So these are the results of the detection of scripts. Now, this only involves 58 questions, not 59, because we had a problem with one question and we excluded it from the data. But you can see that there was 3 scripts that were generative AI in each batch the markers had. So the perfect score was to detect 3 out of 3. And before the training, on the left-hand side, just under 50% of our markers were correctly identifying the 3 scripts as being generative AI. On the right-hand side, after they'd undertaken this training, which was an online training explaining the characteristics of generative AI scripts, it took them about an hour to 2 hours, 1 to 2 hours to do. And after they'd done that training and marked the next batch, that shot up to nearly 80% of our markers were correctly identifying 3 out of 3 of the generative AI scripts, which is great. It means the training worked and it had a significant effect. But we also discovered there was a problem, and that was over the detection of student scripts. So again, if you remember, in each of the batches, there were 5 authentic student answers. And before the training, around 80% of the markers were correctly identifying all 5 as being student scripts. But after the training, on the right-hand side, that dropped to around 55%. So after the training, the marker's ability to detect authentic student answers dropped fairly significantly. And what we discovered when we did the focus groups with the tutors, the markers, was that they really liked the training. They felt that it gave them confidence, and it gave them a language to explain why they thought it was generative AI, when perhaps before they'd been relying on their gut instinct. But also, they started to see the characteristics of generative AI everywhere, including in the authentic student answers. And you can see the quote there from one of our markers. So we thought we'd look into this into a little bit more detail. So the markers were asked when they were marking these scripts to explain in their own words why they thought it was a generative AI answer. And we coded those scripts and we came up with these themes. So the themes were our kind of attempt to classify what they were saying. And you can see the characteristics of generative AI, or the hallmarks of generative AI, are down the left-hand side. The orange line is the number of scripts that they identified these characteristics in that were actually generative AI scripts. So you can see that nearly 90% of the generative AI scripts, they were mentioning issues around tone or language. And style and format was mentioned in around 75% of the generative AI scripts. The modular materials not being used was also mentioned in just under half of the scripts, and it being superficial. But the issue was that some of these characteristics were also mentioned as being reasons why they thought the student scripts were generative AI. So these false positives, and that's the blue line. And you can see that actually some of them, like errors and conclusions and references, are more common in the authentic student answers that were identified in those than in the answers that were actually generative AI. When we looked in a little bit more detail at this through the focus groups, we did discover there were differences between the way that these presented in generative AI answers and student answers. So you can see the quote there, for example, around conclusions. So the markers were saying, I could see the way in which generative AI doesn't really come to a conclusion is different from the way students fail to put forward an argument. Generative AI provided both sides of the argument and then just didn't come to a conclusion, whereas students just failed to put forward that convincing argument throughout. So there were differences in the way that it presented in the scripts. But you can also see that predominantly these kinds of characteristics, such as being superficial, having problems with referencing, making errors, were associated with weaker student answers. So students that struggled with their study skills, that were scoring more poorly, could also display these characteristics that do appear in generative AI answers. The final thing we did was to try and see, could we correlate, could we put together the information about the marking and the grades that the generative AI received and the information about how easy it is to detect. And so we put this information together to see whether there were any question types that may be more robust than others. And you can see here the green is where the assessment scores on the lower side, so a fail to a pass 4 or a third, and where the training suggested, it suggested that the training that they could detect the generative AI and it hadn't got worse. And the types of assessment that came through as being, out of all of them, more robust was the activity plan that we've already discussed. It was assessments that were audience tailored. So the students were asked to write or speak to a particular audience. So to write a blog or to write to an MP or to a member of the public. And those observation by learner, so where the learners had to make observations on what they'd learned, and crucially reflection on work practices. Now, generative AI can reflect really well. So general reflections, it passed fairly easily. But where you ask a learner to reflect on something that's happened within their work context or on something that they've done on the course that you are aware of as a marker, and to provide specific examples, that was more robust. And so generally, it's those types of assessments that's traditionally called authentic assessments that tended to be more robust. So assessments where there was role play involved, where students were having to do tasks that reflected the real world, and those reflections that involved specific reflections on work practices or an activity they'd carried out within class. They tended to be the types that were more robust. So I'll pass over to Mychelle now.
Thanks, Liz. So we had a series of key findings. It's actually quite difficult to distill them down into a short list like this. We absolutely had a key finding around the training of generative AI detection. And as you saw from the data, it improved the detection rate, but it also increased the false positives. And therefore, we felt that the detection actually might not be feasible, that that's not the route to take when we're looking about robust assessment in terms of generative AI. And in addition to the fact that there are false positives, it also takes a lot of time for a tutor for a marker to think about, is this or isn't this student generated? There are no question types that are currently robust, but as you heard from Liz, things like the activity plan, the audience tailored assessment, observations by learners, and reflections on the work practice are a little bit more robust, and others are less robust. So it's really important to think about the question type and how you can actually enhance and develop those as well. Next slide, please, Liz. So we have a series of recommendations. In the first instance, we have some recommendations around assessment. So it's not about detecting the generative AI or knowing the hallmarks of generative AI for detection. Rather, it's really important to understand how generative AI can be used responsibly and ethically, what those hallmarks look like, and then use that information to inform your question design, your marking guidance. Now, my personal opinion is that marking guidance is incredibly important, and how we frame and structure our marking guidance needs to be, particularly at our university. I can't comment on your universities, but I feel we need to take more time with our marking guidance and think about that. And that will really help in informing robust assessment. And then ultimately about having study skill interventions for students rather than just focusing on the punishment of students. Regarding the question design and the marking guidance, the University of Greenwich have a great AI risk measure scale that they use, and there's a link to it in the slide deck. But we would encourage people to put together some kind of a framework for assessing your question design and thinking about those things about the activity plans, the audience tailored, the observation by learners, and so forth, and think about the types of assessment that you are creating. And again, be very clear about what a fail is. And then ultimately, we found some quite interesting responses in the qualitative data around what approach would be most useful. And absolutely, it needs to be a team approach. So as we've seen generative AI and the responsibility for generative AI coming down from maybe a university statement, but down to the individual module team deciding whether or not students can use and in what capacity students can use generative AI. Actually, as an institution, you need to have a whole approach to fostering that responsible and ethical usage of generative AI. So we have found, for example, and as many institutions do now, we have kind of a traffic light system where we have three things. Students can use it freely, students have to use it, or students cannot use it at all. Next slide, please, Liz. Academic conduct and skills are really an interesting concept here, because we found whether or not the answer was submitted through the use of generative AI, or whether the answer was submitted because it was poorly written by the student themselves, actually wasn't the relevant bit. The relevant bit is that the students need support in their study skills. So if they're submitting a poor assignment, work with the student to develop their study skills, work with the student to be responsible and ethical with the use of generative AI. So don't just go straight to academic misconduct and assume the worst of the student. We want our students to be responsible academics, and they're not necessarily going to be able to do that on their own. And the other thing that we found is that some of the markers would speak to the students directly and be supportive with them, whereas others would go straight into the formal process. So therefore, there would be a mismatch of what had happened to a student before a decision was made about academic misconduct. So it's really important that you record the interventions that are happening, whether they're informal or formal, with a student. And then in terms of the conduct referrals,
We have muted you, Mychelle. That happens sometimes when we try to mute participants and we mute
okay,
you, but that's
that's all right. I was like, all of a sudden I was muted. That's absolutely, well, it's not fine,
oh,
but well, maybe it is fine if it's so. I'll come on to the second bullet point there, the conduct referrals. Markers weren't entirely sure where their responsibilities started and ended. So whatever the guidance is for your university or for your institution, make sure that it's clear what the role of the markers are, what the role of the teaching staff are, around academic conduct and skills development and generative AI information, and then make sure that things are proportionate and timely. Don't go straight to the assumption that students are trying to cheat. They might be having a real a life crisis, and actually it's important to find out by engaging with a student about that life crisis rather than just putting through a punitive route. Next slide, please, Liz. And our last set of recommendations here around generative AI training and who to train. Everybody is the answer. so everybody benefits. And I had a really nice something happened to me recently where I had done some generative AI training to all staff, professional services staff and academic staff. And I had one of the professional services staff contact me and say, thank you so much for that training. I've been able to do X, Y, and Z. So specifically regarding robust assessment, absolutely the markers and those who are writing the curriculum and the assessment, and students need the training true. Training needs to be ongoing. As we know, in the last 2 years, we've seen many iterations of and many tools evolving. And then in terms of what the content of that training is for staff, the hallmarks are interesting. It's a combination of hallmarks that maybe would point out more that it's generative AI than not. But as we mentioned, what's really important is about the design of the assessment, the design of the marking criteria, and the information about referral to skills intervention. And then for students, absolutely, it's about upskilling them for ethical and responsible usage of generative AI. I'm going to hand back to you, Liz.
So thank you, Mychelle. If you want any more information, we have a full report available on the first link at the Open University website, and some information on our funder. So this was funded by NCFE's Assessment Innovation Fund. There's some information on their website. And we've also made the training resource that we used in the research. So this was the online training for markers to be able to detect generative AI. That's now freely available, and that's on the third link on the slide. So thank you very much, and we're happy to take questions.
Many thanks, Mychelle and Liz. Thank you so much for this very rich presentation with a lot of practical advice as well. That's really good to see. I saw there's a question from Bhumika in the chat already. She's asking which large language models were used for the generative AI in this case. I think it's ChatGPT, isn't it? Or
yeah,
is it
we use ChatGPT for the subscription model, partly because we were trying to future-proof this. So the research took place between February and June of this year, 2024, and at that point, the most accurate and reliable one that students appeared to have access to was ChatGPT-4. So that's the one that we used. And the other thing I'm not sure we said that we probably should have said is when we generated the answers using ChatGPT, we put the question and the guidance that the students had into the tool, and we took the response and copied it into the document. So the PhD students were doing this, but they were explicitly told not to edit the document. It was effectively simulating a fairly naive user. It was a cut and paste. So we didn't edit the answers at all that we generated from generative AI.
Thanks, it's very clear. Thanks, Liz. Any other questions in the chat, or anybody wants to take the mic? There's a follow-up question from Bhumika, actually. I think you can read it. As a follow-up to this question, would the hallmarks and other characteristics differ per LLM model or with some fine-tuning?
So this isn't based on the research, because obviously the research we did was with ChatGPT-4. I've done some other research around generative AI and access to justice where I've used other models. And what I would say is it tends to be generally, in my experience, the characteristics are common across most of the large language models, because they are based on the fact that it's a predictive language tool. And so you would still get the same issues that arose with ChatGPT. Now, there may be some slight differences depending on the model that you're using. I think the models that now link to the internet and can pull information off the internet rather than just their training resources, I suspect there may be some differences there as well, but we haven't tested that. We simply use the one LLM in our research.
Liz, just to add to that, what I would say is that there is a difference between paid and free models.
Yes. So again, we've done some other research which showed quite clearly that the paid models are more effective, are better, to use a colloquial term, than the free versions, which of course raises a lot of other interesting questions for us around equality and digital poverty and ensuring that our students, you know, are treated equally and fairly.
Any other remarks from the room? So I was wondering, you at some point said things like role play and what you called authentic assessments. They're the most robust. Is one of the advices to say do more of those, or is that not really? I think so. I mean, it might be difficult for a lot of different subjects, but to do role play. But yeah.
Liz, do you mind if I just jump in on that one?
Of course,
I think generally speaking, as the world is evolving, the skills that people need in the workplace are changing. So it's really important that we reflect those skills and we build those skills and that authentic what's actually going to happen in the workplace, or if they're learning for academic careers as well, what's actually going to happen, so that then that can come back into the assessment and through the assessment. So yes, absolutely, more authentic assessment, not just because it's more robust, but it's about preparing students for the future and making sure that they can contribute to society. Liz, I don't know if you want to add any more to that.
I think there's also a question about that from Sarah in the chat, actually. Can you give more examples of the role play type activities? Maybe you can also say something regarding that.
Yeah, so that feeds into what I was going to say. So I think one of the things is for something like ChatGPT, which is pulling from its training data, it lacks that kind of awareness of the context of the world in which we live. And though I think these kind of authentic assessments or role play assessments play into that, that's possibly why they're a little bit more robust, because it requires the learners not only to use the information from the assessment and the knowledge, but then to apply it into a context that the LLMs don't necessarily understand. So the role play assessments were things where students were asked to write for a particular audience. So they were asked to give a presentation to school children on a subject, or they were asked to make some slides to present to a business proposal. So it's those types of assessments where instead of writing for an academic audience, they were asked to write for a variety of other types of people, and that could be members of the public, children, specific businesses, the government, doing a briefing paper for the government, those types of things.
Liz, just in the chat box there, someone had asked about the rubrics. Just clarifying for the activity plan. The rubrics were given, but the materials were not.
Yes. So we gave the generative AI all of the information, the rubrics and the guidance that the students had. They didn't receive the module materials, and they didn't receive, we give our markers specific marking guidance, which the students don't see. And so the generative AI didn't see that, but they saw everything the student would have had apart from the module materials.
Thank you. There's a question, or at least a raised hand from Monica. Monica, would you like to take the mic?
Yes, thank you very much. this is great to have this information. You know, it's really clear, and would be helpful for senior management to see it. Just in terms of the types of assessment, unfortunately, I couldn't attend the session on Tuesday, and I don't know if Henrietta Carbonell spoke about interactive oral assessment, which is kind of an authentic, real-world, unscripted conversation between an assessor and students. And that's one of the ways that is very robust in terms of academic integrity. And it's sort of role play, but it's sort of more structured than that. I'll put a link in the chat of some resources we have here in Dublin City University on that. But it's I'm still in the bright-eyed and bushy-tailed evangelical phase of interactive oral assessments. But it's the one thing, and it works in those transversal skills that people are looking for, to be able to extend and synthesize knowledge so the students can see themselves in their future professional role, where they have to talk intelligently about whatever their particular domain is. So I put some information in the chat because I think it's one of the few things we have left in our arsenal. Thank you.
Yeah, thank you. I mean, in terms of our research, we did include oral assessments, oral presentations, but that was more structured in that it was a type of assessment where students were asked to give an oral presentation on a particular subject. So we generated the script from ChatGPT and had a variety of people read them out. We didn't look at the interactive oral assessments, which I think would be obviously much more difficult for generative AI.
Yeah, and just to clarify that, and you have, as you have done, that an interactive oral assessment is not just a Viva. It's not an oral assessment. It's not a presentation. So thanks for that, Liz. Thank you.
Let's take one more question from Kamakshi. There's also a few in the chat, but maybe Mychelle and Liz, you have time to answer them afterwards, and we move on to Sami after a question by Kamakshi. So please go ahead, Kamakshi.
I just, because I joined the session late, so I just saw the last few slides. But one thing I noticed in what you were saying is that you said that especially in the foundational tasks, let's say, the ChatGPT or generative AI was scoring better, if I understood it correctly. I was wondering, how do you think, because I mean, our assessments could become like assessments for expert students when they have not had the basic foundations yet. So how do you think we should protect those, and how do you think we should approach teaching those foundational knowledge and skills to our students?
That's a really difficult question, and one that the team haven't kind of come up with an answer to. We need to teach our students foundational knowledge. We need to teach our students foundational skills, and yet they can be very easily answered by generative AI. So the sorts of discussions we had within the project team was, could we make those sorts of could we assess that formatively so that there's no marks attached to it, which removes the incentive for students to use generative AI, whilst explaining to them how important it is for them to learn these skills, and perhaps reserve our assessed tasks for the assessments that involve the higher thinking skills. There is the possibility of oral assessments. There's the possibility of exams, but we're really in some ways we're reluctant to go down that route because we have about 25 to 30% of our students have declared a disability, and we know that high stakes assessments like Vivas and like exams can be quite problematic for those students. So we might be introducing further problems and further awarding gaps. So I don't know, Mychelle, if you've got any more thoughts, but yes, it is a real problem, particularly at those lower levels and that foundational knowledge. And I don't think we've got a complete answer yet for it, other than acknowledging it's really difficult.
Yeah, but I would draw an analogy to the calculator, right? And how people add, subtract, multiply, divide, and so forth. And that has obviously changed. People could do much more complex calculations in their minds probably 30, 40, 50 years ago. So I think we think about that evolution here as well, as what is it that's essential that people know without the use of something else? And then what is it that it's okay actually that they refer to get that information, and then what are the skills that are actually important as we reflect forward, and how can we support the development of those skills. And the final point, Stefan, is about the higher levels of critical thinking. I challenge anyone who says, oh, we can only do higher levels critical thinking at the higher level of university study. Get your students using critical thinking and higher level critical thinking as soon as you can. Right, and that makes them stronger for the workplace as well. So I would challenge the regurgitation as not actually appropriate anymore, or ever, maybe, I don't know.
Thank you.
Yeah, thanks a lot, Mychelle and Liz. Thanks for the presentation. Feel free to stick around for the next one, which is by Sami Suhonen. He is a principal lecturer at the Applied Research Center of Tampere University of Applied Sciences. And Sami will talk about how AI is transforming STEM assessments at his university. So please go ahead, Sami.
Thank you, Stefan. So my background is in engineering education. So I'm sorry, but you will see a couple of examples coming from physics. So this is not only about online courses, but also in recording face-to-face teaching. And now I'm talking about kind of an example or a story how AI has transformed STEM assessment in our university in Tampere in Finland. And let me start. So this story starts from last winter, when I personally had an awakening to the AI era regarding assessment in engineering physics. That was a thermodynamics course. Then after that, we started to do some tests with AI and rethinking assessment in our online courses, but also what comes to on-site courses. And then at the end, I will give you an example of one of the courses of this year, which is mathematics, physics, and radiation physics for radiography nurses. So I will start a year back. And thermodynamics, I think you all know something about it. And I had a question on my online course about isochoric processes, and I asked the students to find and describe one process in their everyday life. And I was expecting answers like car tire, when it's heating up, the pressure will increase, or what we all know, if you close the fridge door, it's difficult to open because the temperature drops and the pressure drops. So that was what I was expecting, and what I got as an answer in an online course. Traffic at an intersection is a complex isochoric process, blah, blah, blah. And many weird things came up. So this was a kind of a wake-up call for me that I can't continue with this kind of questions anymore. And maybe I hope it was a wake-up call for the students as well when I gave some feedback about their answers. There was nothing from the course contents, and they were not even real physics. Okay, so let's move on. And then we made some tests. And again, I'm sorry, now comes some physics. So what comes to thermodynamics, very kind of basic question about what happens when you bring in heat to a system that is insulated. And the question was to sketch a graph of the temperature as a function of time. And I tried with AI tools that were in use at that time. So ChatGPT 3.5, but also ChatGPT 4, Gemini, and Copilot. And I'm not going into details. Anyways, I asked the same question, the previous question, of all of these AI tools, chatbots. And many of them were not able to provide any graphs. They gave an answer in text. And based on that text or written description, I then draw the graphs like the AI tools gave it. So all three others are quite crap. ChatGPT 4 did rather well. There are right elements, but even that is not exactly right. And Copilot did rather well too, but not exactly right, that one either. So this far, already some concerns that the students can use Copilot even in that kind of, or ChatGPT in that kind of questions. Then tests continue. Let's move on to mechanics. Bachelor's level engineering physics. What are the forces acting on a car traveling on a horizontal road at constant speed? And what you would expect, what the students should find out, are the forces seen in figure A. And all those chatbots, they gave some ideas. They usually find the concept of equilibrium rather well. They gave forces rather right: gravity, normal force, rolling friction, traction, air tracks. But none of the chatbots were able to actually position those forces correctly. And what comes to the free body diagram, like in the picture A, we all know that chatbots are more artistic than scientific. And the answer for that is in picture C. So nothing to do with physics anymore. Then a third type of test in STEM, in physics. This is the actual handwritten answer to a question given to chatbots with the question, is this calculation correct? And for you to know, the first part, the temperature is right in this one, but the volume is not. And what came out, other chatbots were not able to do almost nothing with that, but ChatGPT-4 actually provide quite nice answers. So it provided the stepwise calculation, which was correct for the temperature part. But what comes to volume, it didn't calculate it correctly. The formula is right, but the result is wrong. And again, when that is pointed out to the ChatGPT, then it's able to correct its answer. So this all led us to have a try with a bachelor's level engineering thermodynamics exam. How would ChatGPT-4 score in that? So the questions were partially written conceptual questions. Many of them were numerical problems, and they included tables and diagrams, and all that was given to ChatGPT-4, and it got a grade 3, 21 points out of 30, which gives it an average grade of 3, where 1 is the lowest and 5 is the highest, all passing grades. So already almost, not exactly a year ago, but more than half a year ago, ChatGPT would score quite nicely in the final exam. So what does it mean for us if we are considering online courses or assessment in face-to-face courses, having some home assignments? They don't work so well as a basis of grading anymore. It doesn't measure student skills in physics or the understanding physics, but rather in prompting. So what else do we have then in physics? Well, physics is, of course, an empirical science, and that has to be a part in learning as well. So at bachelor's level elementary engineering physics, we have measurement tasks for the students. So let's have a look, how do those work in this AI era? And this is an example of that kind of assignment. Students are asked to find a plastic bottle with a constant diameter, then make a hole, put a piece of straw in it, fill it with water, and then let the water flow out and measure the height and the outflow range when the water flows out of the bottle. And with this, it's possible to calculate something called coefficient of discharge. And this is an actual picture of the measurement. And despite the very simple tools, it gives surprisingly nice results. So it works well as an assignment students can do at home, even the online students, online courses. So I tried this with ChatGPT, and I asked to help with the measurement assignment. And as long as it's only about the instructions, everything is fine. It gives rather nice instructions how to proceed. Everything correct. Of course, many of these points were already given in the assignment itself. So not so much new here, but it kind of gives a nice stepwise guide anyways. Then what comes to the calculations, and this was of course something that the students are supposed to learn and know themselves, not ask the ChatGPT, but ChatGPT in this case did everything correctly. Then I asked about to draw a sketch. How would the result look like? Again, they are not good in doing any kinds of graphs and not any diagrams. So this is of course just nonsense. And this was not what I meant. I rather would have seen the actual results, the coefficient of discharge as a function of outflow velocity. And this of course looks nice. The axes are okay, but the graph itself is, the data points, they are not following the laws of physics. So this is incorrect. Correct. Looks nice, but there is nothing right. So it means that, yes, we are still able to use measurement tasks in our assessment, but we need to kind of take into account that students can use them to collect the relevant equations and derive the equations, and they are then not actually doing it themselves necessarily. So that needs some rethinking of the measurement tasks as well. But it works better than home exams, for example. Okay, so I will now move on to an example regarding course mathematics, physics, and radiation physics for the radiography nurses. So what does all this mean in classroom teaching? And this course is in two parts. First part is mathematics and physics, and the second part is radiation physics. And the group entering this course is very, very heterogeneous. Some come from vocational school, some come from high school, and their mathematics skills are very at very different levels. Nevertheless, everybody needs to get to the right level to be able to proceed to radiation physics part. So the problem is that some people on this course need a lot of practicing, and for others, everything is rather easy in the first part, the mathematics and physics part. And sometimes those groups have rather large exam anxiety as well. Previously, this course was arranged so that the grade was based on automatically scored Moodle exam. The students took at home with all materials. There was a time limit, and they had 3 attempts. Of course, for each attempt, the questions were randomized and the initial values were randomized and so forth. But now, due to the ChatGPT, this doesn't work anymore. So what did we do? We still use the same Moodle exam, but now for practicing purposes. So the students can take it as many times as they want at home to practice for the real exam, which now takes place in a classroom, and it's supervised, but still in Moodle. And as already I have shown you in the previous part, the ChatGPT 4 was by far the best in physics, and therefore we recommended to the students in this course, in this radiography course, 2 AI tools, Photomath and ChatGPT, but also Copilot, which is our university's official AI tool. And if you don't know Photomath, it is a handy tool for basic mathematics. You can take a photo of any calculation, even handwritten, and it then guides you through the steps in solving the problem. And for ChatGPT, the students were provided with the short instruction videos, which also had some prompts included in the videos. And the students were asked or recommended to use AI tools to check their own calculations and help them to go through the stepwise solutions of the problems, but also to generate more examples for themselves. So they don't always need to ask the teacher to provide more practicing material. They can do it themselves. But of course, remembering that it's better not to take a shortcut, but rather use AI to guide in learning. So what did we find about the student experiences of using AI tools in their studies? And what did this change in the assessment method bring to us? Previously, they had a online exam they took at home with 3 attempts. Now they had a classroom exam, 1 attempt only, with no materials. Okay, the data was collected by 2 methods. First, a form survey about the impact of the AI tools in students' learning and learning experiences and the perceived benefits. The forms had multiple choice questions and also open-ended questions. And then also I had a look at the learning outcomes recording final grades of the 2 cohorts, 23 and 24. And the time and points they gathered in Moodle exam. And how does it look? Let's start by having a look at the final grades on the left side. So 2023 cohort had a exam at home in Moodle with all materials. 24 cohort had an exam in classroom with no materials. The group sizes are rather small, so the changes are not statistically meaningful, but nevertheless, there is a hint that there is at least no decrease in the final grades. It seems that there is even a better grades in the 24 cohort. And what is maybe more interesting for a teacher's point of view is the graph on the right side. It shows the exam points on the x-axis and then the total attempt time in y-axis. And for the 23 cohort, the time limit was 2 hours per attempt. So 6 hours altogether. For 24 cohort, they could practice as lot as they wanted with the Moodle exam at home. And the main result is, of course, not a surprise. The more you practice, the more you learn. There is a nice correlation between the final points and the time they have spent. But for me as a teacher, it's nice to see that those students in the 24 cohort, they have practiced even 6 hours with the exam before they came to the real exam. That's very nice. And what did they use AI tools for? And what AI tools they used? One student could have used, of course, more than one. So of those who answered these questions, most of them had used Photomath, also ChatGPT. Some used Copilot and Gemini, and some didn't use any AI tools. And how did they find this? The AI learning tool was helpful in my studies, and the ranges from strongly disagree to strongly agree. And as you can see, all of them agreed or were neutral. Nobody was against using AI tools or against the idea that it was helpful in their studies. Most of them actually strongly agreed. And they used AI tools to in difficult calculations or difficult concepts, also to speed up their own calculations. Some reported that they provided new learning opportunities, and some reported that there was no significant benefit at all. Anyways, here are a few comments from the student feedback. I like that AI assistants were introduced in Moodle, and they were also mentioned in the first class. Perhaps the threshold for using them could be lowered further by adding an example sentence in Moodle on how to ask ChatGPT to complete exercises on a specific topic. And encouraging their use was a very positive surprise. In my previous studies, AI was not used at all and was rather seen in a negative light. Emphasizing its useful side is, in my opinion, only a good thing, and this should be actively done in the future as well. So let me summarize. The AI tools, they are advanced enough to serve as a personal tutor in learning physics in many cases. Of course, caution have to be taken and the results have to be checked. But anyways, they work rather well already. And they enhance the students' learning experiences by providing step-by-step solutions and helping in difficult concepts. What the students think of them, they liked it quite a lot. I would say surprisingly a lot, that we had this kind of a element in the course. And what comes to assessment, well, I think we can't use these kind of unsupervised Moodle exams or graded homework anymore. It doesn't measure student knowledge anymore, but they still can be used for practicing purposes. And then the classroom can be, the exam can be in classroom. That's of course fine. But measurement assignments in physics, they still work rather well, even though AI can help in solving those problems as well. Okay, now I have given you kind of an example of what we have done in our university regarding physics studies and what kind of findings we had. And I think these were quite in line with the previous presentation as well. So thank you so much. And I think we have some time for questions.
Thanks a lot, Sami. Really nice to see. So really nice to see how you turned it into a tool for help getting better educational results rather than fighting it. I guess that's the way to go. But also found your quote interesting. You said AI is more artistic than scientific. So that's probably a difficult one to match with getting it for better results. But let's check the room for some questions. I saw there's a remark by Lai Jiang in the chat, which was one on the slides that you showed. See, Lai's asking how to interpret the left one. What does 1 to 5 mean? I think maybe you can shortly put the slides up again.
Yes.
It was one of there were two graphs side by side, and I think
yes, just
Lai's
a second.
on the one on the left. Yeah.
This one?
Yeah, exactly. Yeah.
What was the question, please?
How to interpret the left graph? What does 1 to 5 mean? Lai's asking.
1 to 5.
Yeah. On the bottom, there's 0, 1, 2, 3, 4, 5. I think these are the grades, I guess, that they received.
Yes, on the left side image, the 0 to 5, they are the grades.
Exactly. So they only go up to 5, I guess, the grades. Yeah.
Yeah.
Fair enough.
0 is a failing grade.
Okay. Yeah. Lai has another question. Can you share a bit more? Can you share some experience on how building AI in Moodle for students use? Sorry, I'm just trying to interpret the question here.
Go ahead.
On how to build. Maybe you see it as well in the chat. Lai, you can also take the mic if you like it. You can explain what you mean.
Yes, just because during the exam, your narrative, I heard you are saying that you integrate Moodle, integrate AI on Moodle. So I was just curious, when you're letting students do the home exercise, is AI built in, or the student just using AI separately from? from Moodle. Yes.
Yeah, they are using it separately, but it's of course very easy if you are having an exam in Moodle to copy paste the questions to AI chatbot and then copy paste the answers back. So that's how I expect them to use it.
Okay. Yeah.
There's another comment from Katja. I think it relates to the same. I was wondering about the same. How did you integrate generative AI into Moodle?
I didn't.
Okay.
No. Sorry if I was misleading in that sense.
Okay.
I'm using Moodle and AI on the course, but not combined.
Fair enough. Any other questions for Sami, chat or Mike or otherwise? You can also raise your hand first. Nothing yet? Okay.
Just a small curiosity. I also know you have done this testing some time ago. Nowadays, you have the chat for all. Have you tried it? Did you see in your subject, can the ability of the software enhanced or not?
That's a very good question, and I haven't used or tested the same questions again. I probably should do that soon. But based on my own use of the latest version, I think there is no significant changes in recording understanding physics. So I expect there is no big changes, even if I try the newest version.
Yeah, thank you.
There's a comment by Hugo in the chat saying that Moodle 4.5 allows for AI integration. So that's maybe good to know. Maybe you knew that already. I think seeing that there's no questions anymore, I'd like to thank Sami a lot for his presentation. Thanks a lot for being here. Also to the previous speakers, Mychelle and and Liz being here. Thanks a lot. I'm almost letting you go, but not before I did some promotion of our next webinar week, which is going to be on retention in online and distance education. So it's really about how to deal with improving engagement and retention rates in online and open education. So please, I'm just going to put the link to the event in the chat, and feel free to sign up. It's on the 16th and 17th of December. All the materials from this week will be shared before the weekend, and I would like to thank you all for participating and hope to see you again later this month. Thanks, everybody.
Thank you.
Thanks.
Thank you.
Thank you.